In today's lecture, we will start from the point where we stopped in the last lecture and then we will continue. Basically, in the last lecture, we have learned the concepts of tangents, concepts of normals. We have derived all equations and then we were learning some applications of those concepts. So, among them we have learned how to derive director circle, what is its nature, and then we were doing some properties of tangents. Okay. So, we will start from where we left and then we will continue. Okay. So, basically we have learned all these equations and we proved this property using simple geometry. Okay. So, now let us prove the next property, which is the reflection property. So, reflection property is very famous property for conics. We have also seen one reflection property in parabola. Similarly, we have one reflection property in ellipse. So, here the first property is, if a ray of light passes through one focus, passing through one focus, gets reflected, there is this apostrophe, that is typing error. So, gets reflected from the ellipse, then the reflected ray passes through the second focus. So, let us prove this using simple geometry. We have one ellipse here, okay, we have one ellipse here and there is this major axis. We have one focus here which is S, another focus here which is S dash. Now, any ray that is passing through S, let us take this as one light ray. Okay. So, this is one light ray which is passing through S and getting reflected on the curve. Now, if I take this point as let us say P, this reflected ray must be passing through S dash, that is the property. So, here whenever we understand this incident ray, reflected ray, we have to compare it with the normal at that point. Okay. So, we have already seen that in physics. So, if we apply it here, what do we get? We need to form one normal here. So, about normal, it has to be symmetric. Okay. So, if this angle is let us say theta, this angle also will be theta. So, basically here these two, incident and reflected ray, are reflections of each other about the normal. Now, is it a new property? No, of course, this is the same property as the earlier property, which says the normal bisects the angle SPS dash. That is exactly same as this idea that this normal is bisecting the total angle. So, basically this property, reflection property, is same as the earlier property, where we have proved that normal is basically the angle bisector of this angle. If normal is angle bisector, then these two rays are basically reflections of each other. Okay. So, this reflection property is very important property and that is same as the earlier property that we have learned. Okay. So, we have proved the first property. Let us look at the second property. Locus of foot of perpendicular from focus on any tangent of the ellipse is auxiliary circle. So, that means here we have to form some tangents. So, let us remove all these diagrams, but keep the ellipse. Okay. So, let us say there is one tangent here. Okay. And let us take this point as P. What is the property? Locus of foot of perpendicular from focus. From focus means foot of perpendicular must be drawn from the focus. So, from here let us say I have drawn one foot of perpendicular and if I take this point as let us say F. Okay. So, what do we have to prove here? This F lies on the auxiliary circle. So, let us take one point and let us prove this property. Okay. So, to prove this, let me just change the marker. We know that the focus is AE comma 0 and if this point is let us say A cos theta, B sin theta, then equation of tangent becomes x by a cos theta plus y by b sin theta is equal to 1. That is the equation of the tangent, and we need foot of perpendicular. Okay. So, we can find the equation of the line which is passing through this focus and also perpendicular to that line, and solve for the point of intersection and find the locus. This could be one method. Whenever we are finding the locus of point of intersection of two lines, what do? We always try to eliminate the parameter directly without solving for the point. This way we can solve it faster compared to the other idea of actually finding the foot and applying the concept of director circle, eccentric circle. Okay. So, that means there are two methods here. One method is we can find the coordinates of this point f by directly applying the formula of foot of perpendicular, and then we can prove that distance from the center to this f is always going to be equal to a. We can prove it, or the other case is we can directly find the equation of the line which is perpendicular to the tangent and passing through this point, and then we can eliminate theta directly. Okay. So, suppose here if I find the equation of the line which is perpendicular, how do we do that? How do we find any line which is perpendicular to this? Just swap the coefficients of x and y. So, that means here I will write x into sin theta by b and y into cos theta by a. I have swapped the coefficients, now put minus sign. So, this will give me LHS. Now, how do we find RHS? To find RHS, put this point AE comma 0 in this. Okay. So, if I put AE comma 0 in this, what do I get? AE sin theta by b. This is the equation of the line perpendicular to the given line and passing through AE comma 0. Okay. So, now I am interested in eliminating theta directly. Now, think about a step which will directly eliminate theta here. Is there any step which will directly eliminate theta? So, here if we observe, there is cos theta here, there is also sin theta here, cos theta, sin theta. Any standard idea of eliminating it? Just calculate sin theta and cos theta from here and try to square them up and eliminate. Okay. But this could take a while. Okay. It could take some more time because solving this involves significant degree of simplification. Okay. So, let me just simplify here. So, we got x by a cos theta plus y by b sin theta minus 1 equal to 0. Okay. The next one, if I take sin theta common, so or cos theta common, so let us say take everything to RHS. So, we get cos theta into y by a plus sin theta into x by b plus AE by b equal to 0. Now, we know that these two linear equations are there, and just imagine if we treat sin theta and cos theta as different values and apply Cramer's rule on this, we can directly get sin theta and cos theta, and we can put sin square theta plus cos square theta equal to 1. Okay. So, we can use that idea. So, how do we do that? So, I will put cos theta here, sin theta here, 1 here, and coefficients of sin theta will come here. So, which are y by b and here x plus AE by b, and the constants will come here minus 1, 0, and next coefficients of cos theta will come here x by a and here y by a. Okay. And next here we will have again repeating this y by b and x plus AE by b. We will have again these repeating terms which are coefficients of sin theta. Now, we can get cos theta and sin theta directly from here using the Cramer's rule, and then we can put cos square theta plus sin square theta equal to 1. So, this way we can eliminate theta directly. Okay. So, now we can proceed with the solving. So, what do we get here? Cos theta divided by, this is anyways cancel 0, and here we are getting x plus AE by B is equal to sin theta by, this is anyways 0. So, here we will get minus y by B is equal to 1 by, what do we get here? X into x plus AE by AB minus y square by AB. This is what we got. So, directly get cos theta here, sin theta here, and then cos square theta plus sin square theta equal to 1. Just put that condition, you will get the locus. Okay. So, let me simplify it. There is also other idea of solving here, but that may take longer time. If you just square them and add, you may get some terms which are of very standard form, but that you can do at later stage. Okay. So, let me just proceed now further. Cos square theta plus sin square theta is going to be equal to or let us say divided by, what I am doing? I am doing basically the ratio and proportion ideas. So, this is going to be equal to x plus AE by B whole square plus minus y by B whole square divided by, what is the denominator? Denominator is square of this, x into A plus x plus AE. So, AE plus x divided by AB and minus y square divided by AB whole square. Okay. So, now just because this is 1, so just take this to LHS and simplify it. So, it becomes x into x plus AE minus y square whole square by A square into B square is equal to, here we are getting x plus AE whole square plus y square by B square. So, here we can get B square cancelled and we can simplify it. So, while simplifying, just simplify it only in terms of these terms. Okay. So, basically here I am getting x square into x plus AE whole square plus y square into y square minus 2 x into x plus AE into y square is equal to A square into x plus AE whole square plus A square into y square. Okay. So, now when we simplify this, we will get some perfect factors here. Okay. So, what are the factors that I am getting here? There is A square into y square here. Okay. So, this is going to be little longer. Okay. But just stay. So, x square minus A square into x plus AE whole square plus y square into y square minus A square, this is what we got, and there is one more term here which is y square. Okay. Okay. Into y square is equal to 0. Okay. So, let us see if we can factorize this. So, anything else? Okay, so somehow we should be able to get a factor here and get the answer. This is one method. Okay. So, I will leave this for you to complete the method, but then I will solve this question using a different method. Okay. So, if you can take a snapshot of this, I will solve this question using a different method, which is the second method. Okay. Come on. Okay, next page also. So here, what is the other idea? Other idea is this. Suppose let us say I remove all of them and I take the tangent as y equal to mx plus root of a square m square plus b square, and that way also we can solve this question. Okay. So, let me just show that to you. So, here also algebra is going to be little long, but you can finish it on your own. So, let me just give you the idea here. Suppose if I take this line as y equal to mx plus minus root of a square m square plus b square. Let us say this is my tangent. Now, what about the line here? This line will be having the slope minus 1 by m. So, we can get the equation of this line as y minus 0 by x minus ae is equal to, it will become minus 1 by m. Now, if I simplify this, I get my plus x. So, I am basically taking x minus e to RHS and then taking them to LHS, and this becomes minus e equal to 0. So, basically equation looks like this. We have one term which is mx minus y whole square is equal to a square m square plus b square. This is what I got from RHS, and we have one which is like my plus x whole square is equal to a square into e square. But we know that we can write b square as a square into 1 minus e square. Okay. So, here RHS can be simplified directly. Okay. Or we can also write a square e square as a square minus b square. Okay. So, here we can write a square minus b square here. Okay. But the problem is we have the term with m which is creating the problem, that we will deal with after a while. Okay. So, suppose let us say we square these two and add them. What do we get? When we square these two and add, we do not have to square, it is already squared here. So, we will get m square x square plus y square minus 2mxy is equal to a square m square plus b square. This is one term, and the next m square y square plus x square plus 2mx y is equal to a square minus b square. Now, when we add these two, what exactly is happening here? You can notice that this xy term is getting cancelled, this b square is also getting cancelled. Now, here when I take x square common, I am getting 1 plus m square, and also when I take y square common, I am getting 1 plus m square, and in RHS I am getting, when I take a square common, I am getting 1 plus m square. So, here if you notice 1 plus m square is common in all of them, we can cancel this because 1 plus m square can never be 0. So, hence we are getting this equation x square plus y square equal to a square. Okay. This is the fastest method. Okay. So, when we solve questions like this, we always have two paths available. One is either we can go for the parametric form, which is 90% of the time easiest to solve, but there is also one more method which is using the slopes. Okay. So, when it comes to tangents, always keep this slope form as a floating idea in your mind, because sometimes using this form we can solve questions very faster. Okay. So, here we have solved this using the slope form. Okay. So, I wanted to give both methods, I have given both of them. Okay. Come on, take a snapshot of this also. Okay. So, we will do the next property now. We got the auxiliary circle here whose equation is this. Okay. Next, the product of perpendiculars from the foci on any tangent of the ellipse is b square. So, basically if we take this tangent and from foci, let us say we draw two perpendiculars, we have to prove that product of the perpendiculars is always going to be equal to b square. So, let us try to solve this problem in the similar manner. Okay. So, how do we do that? So, let us just erase this and solve it using this idea. Okay. So, let us just solve it using this idea. Now, this point becomes AE comma 0, that is one focus. The other focus is minus AE comma 0. And from here also we are drawing one perpendicular. So, from here there is one perpendicular, from here also there is one perpendicular. We can name this as D1, we can name this as D2. Okay. And we want to find the product of these D1 and D2, product of perpendiculars from foci. Then how do we do that? We have taken one tangent here. Okay. So, instead of going for plus minus, we can go for any one sign. Okay. So, we can go for only plus sign or we can go for minus sign also, because we are taking only one tangent here. Okay. So, if we are putting plus minus sign, that means we are actually leaving a room for the other case. Okay. So, let us take only one tangent. In the earlier question also, because we were squaring it, so plus minus did not have much effect on that squaring. So, but when you are solving problems, it is always better to go for only one tangent, that means only one sign. Okay. So, let us take distance from this point. Okay. So, the tangent can be written this way, mx minus y plus root of a square m square plus b square is equal to 0. Now, my d1 will become, so let me directly write d1 into d2. So, my d1 will become mod of, you know the formula, you know the drill. So, I have to put ae comma 0 here, that will give me m into ae plus root of this term divided by root of 1 plus m square. Now, what about the other perpendicular distance? It will be in similar manner, we have to substitute minus ae comma 0, that will give me minus m ae plus root of that term divided by root of 1 plus m square. Now, because these two are looking like a plus b into a minus b, we can directly multiply them. So, what do we get here? We get one single mod m square a square into e square plus, no, it should be minus because it is a square minus b square. Okay. Or in other words, this term should be having the minus sign. Okay. So, plus a square m square plus b square divided by 1 plus m square, because there are two terms with square root here and they are getting squared. So, now to simplify this, again we have to use that idea that a square e square is nothing but a square minus b square. Okay. So, if I simplify this, what do I get? So, minus m square into a square minus b square plus a square m square plus b square divided by 1 plus m square. This is the term inside the modulus. So, let me just simplify this and put the value directly there. So, here we can notice that a square m square is actually getting cancelled with this a square m square. Now, what is remaining is m square into b square plus b square by 1 plus m square. Now, luckily when I take b square common, 1 plus m square is basically getting cancelled. So, that way we can say that this product is basically equal to b square. So, this is again one more property which we can use while solving problems also. Okay. So, this way we can prove this property. I hope you have understood this. This is very simple idea. We always take this form to solve problems in a simpler manner, especially when it comes to tangents. Okay. Come on, take a snapshot of this. Okay. So, basically we have proved all three properties here. Now, why am I stressing on proving all properties on your own? Because proving properties will actually give you methods. Now, I have solved them in a different way, you might be solving it in a different way. During the process, you will be experimenting, you will be learning new things and you will be applying those things. So, basically in your mind you are building a structure, you are building a solution to the problems. Okay. So, if you go through this process in the exam or anywhere, when you face any problem, when you are solving any problem, your mind is very intuitive and it will think very fast. Okay. Let us look at the other properties. The portion of tangent between the point of contact and the directrix subtends 90 degrees at the corresponding focus. So, let us prove this also. So, let us say there is this ellipse and point of portion of tangent between the point of contact and the directrix. So, let us say there is one directrix here and this is my tangent. Now, what is the portion that is cut between the point and the directrix? This is the portion. And this portion must subtend right angle at the corresponding focus. When we say corresponding focus, we should be taking only the focus which is nearest to that directrix. Okay. So, let us say there is one focus here which is S. So, this PM is going to make 90 degrees at this S. So, how do we do that? Simple, take one point here either in form of h comma k or in form of a cos theta b sin theta. Now, here which is better? It is better to go for a cos theta b sin theta because we need the point here and we need the slopes. So, this way doing it will be faster. In the earlier case, doing it with m was faster, not with the theta, but here doing it with theta will be faster. Okay. So, if I take this p as a cos theta b sin theta, then equation of this tangent will become x by a cos theta plus y by b sin theta is equal to 1. Okay. So, now when I put it here, so basically I want to find out the point of intersection of this tangent with the directrix. So, when I put this value x equal to a by e in this, I will get one coordinate which is the y coordinate of m. Okay. So, if I just put this a by e, so what do I get here? I get e cos theta plus y by b sin theta equal to 1. So, we will get y equal to 1 minus e cos theta into b divided by sin theta. So, we got the both coordinates of m, x coordinate is a by e, y coordinate is this. Now, let us just get these slopes m1 and m2. If this angle is 90, m1 into m2 must be minus 1. So, that way we can prove this. Okay. So, basically m1 into m2 is going to be b sin theta minus 0 because this focus is ae comma 0 divided by a cos theta minus ae into the next slope 1 minus e cos theta into b by sin theta, this is the numerator, divided by a by e minus ae. Okay. So now let us see if these terms can get cancelled or not. So here if we notice this sin theta can get cancelled. So let me just simplify them. So we are getting b into sin theta, and here we are getting 1 minus e cos theta into b. Wait, there is a mistake here. It is a by e, which means it must be cos theta by e. So here we have been doing that mistake. So let me just correct that. So here it must be 1 by e cos theta, 1 by e cos theta, and similarly here also 1 by e cos theta. Okay. So we can write it as e minus cos theta divided by e. So divided by e we can put here, and here if I take a common, I will get cos theta minus e, and here also if I take a common, I will get let us say if I take a by e common, I will get 1 minus e square. Now let me simplify this completely. So cos theta minus e can get cancelled here with 1 minus sign. There is one sin theta here which will get cancelled with this sin theta. What else is there? E and E are getting cancelled. Okay. So we are getting b square in the numerator, and in the denominator we are getting a square into 1 minus e square, which are also equal. So I will just put them. So if I cancel this, I have to put 1 minus sign here. So basically I am getting b square by a square into 1 minus e square, and these two are anyways equal, so it is minus 1. This way we can prove it, and this is also very basic only. Okay. But here going for a cos theta and b sin theta gives us the faster answers. Okay. So can we proceed? If you take a snapshot, we will proceed to the next property. Next one, if any tangent meets the tangents at the major axis at P and Q, then PQ subtends a right angle at every focus. Hence the circle with PQ as diameter passes through two foci. So let me just prove this. So here we have one ellipse. We have one ellipse, and this is the tangent at this vertex. So we have to make sure that tangents meet tangents at the vertex. Okay. So there is one tangent at vertex here. There is another tangent at vertex here. Let us say there is one tangent here at a point P. Let us say this point P is something. Okay. So we'll make a choice whether to go for theta or whatever, that we will see little later. So let me just analyze this using diagram. Okay. So now there are 2 points of intersection here. So here we have to prove that this PQ subtends a right angle at every focus. So that means, let us say if I take this focus as S, so we have to prove that this PQ, so we cannot take this point as P, so let us take it as some other R. Okay. So this is Q. So this PQ must be subtending right angle at the focus. So how do we prove it? The same idea. Let us take one equation of tangent in this form. Let us find one point of intersection like this. We already have one point of intersection here, okay, which is this. Now similarly for the other, we do not have, this is with the directrix, we will just get it now. So similarly we will find the other point of intersection and then apply the m1 m2 equal to -1, and then we will get it. Okay. So let me just quickly do it. So equation of tangent here is x by a cos theta plus y by b sin theta is equal to 1. If I put, let us say x equal to a here, if I put x equal to a, because on this line x is always equal to a, on this line x is always equal to -a. So I will get the point Q as a comma. So when I put a here, I will get y as b into 1 minus cos theta by sin theta. Similarly, I will get p as, p is the other point of intersection. For that we need to put x equal to -a. So for that we will get -a into minus a comma b into 1 plus cos theta by sin theta, because there is only difference of minus 1 here. So, that will make sure that this sign becomes plus. Now, if we take the slopes, that means let us say this point is AE comma 0. So, if I just take the slopes, what do I get? M1 into M2 is equal to B into 1 minus cos theta by sin theta divided by, what do we get? A minus AE. So, that becomes A minus AE here. This is my first slope. Now, the second slope will be B into 1 plus cos theta divided by sin theta into, again when we take the slope here, what do we get? Minus A minus AE, that will become minus 1 into A plus AE. So, now 1 minus cos theta into 1 plus cos theta will get cancelled with sin square theta, okay. And there is one minus 1 sign here, there is b square in the numerator, and there is a square into 1 minus a square in the denominator, again we are getting minus 1. So, this means we have actually proved this property also, okay. So, I hope you are liking this analysis, okay. So, every time it is better to prove all the properties on your own. I am just laying down a path for you to follow, so that on your own you will develop all these skills, okay. So, now look at this, we have proved 5 properties till now. Hasn't this experience given you a thought of what to do when a question comes? When to apply A cos theta, B sin theta, when to apply M ideas of slope. So, these you will get only when you practice questions and practice this kind of proofs, okay. So, that is why I recommend you to prove all properties on your own, okay. So, here we have proved total 5 properties. Now, let us solve some problems based on these ideas, okay. Okay. So, first problem, find the locus of midpoint of the portion of tangent between the coordinate axes, okay. So, so here basically we have one ellipse, this is one axis which is the x axis, and also it is the major axis for the ellipse, and we have one tangent. Let us say this is my tangent, okay. This tangent is intersecting x axis at one point and y axis at another point, and we are interested in finding the locus of midpoint of the portion of the tangent between the coordinate axes, okay. So, that means if I take this midpoint as let us say P, which is h comma k, we are interested in finding the locus of this midpoint. So, how do we proceed with this? Here tangent is the one which is actually cutting this x axis and y axis at these 2 points, and point is also the midpoint of this. So, we start with the idea of the equation of tangent in parametric form, x by into cos theta plus y by b into sin theta is equal to 1. This becomes our equation of tangent. Now, if I find the x intercept and y intercept here of this line, what will they become? This point, let us name it as A, let us name this as B. So, the point A will come when I put y equal to 0. So, if I put y equal to 0 here, I will get x equal to, you see what happens here, we will get A by cos theta comma 0. And similarly, if I put x equal to 0, I will get the point B, that will come out to be 0 comma b by sin theta. So, here we got the points A and B. Now, we are interested in the midpoint of A and B. If I take a midpoint as h comma k, in general we take the locus point as h comma k, because now that I have got these points, now I am getting even easier idea. Instead of taking h comma k, I will take directly the point as x comma y only, because it is easier to eliminate theta here directly by applying the midpoint formula, okay. So, that means x must be equal to A by cos theta plus 0 by 2. Similarly, y must be equal to 0 plus b by sin theta by 2. Now from here we can get sin theta and cos theta. So here cos theta will become a by 2x and here sin theta will become b by 2y. So just eliminate theta directly, you will get the locus. So that means a by 2x whole square plus b by 2y whole square, this must be equal to 1. That becomes our equation of locus. So whenever I am also attacking problem, I am also solving like a student. Okay. So of course, because I have set these questions and I have put them on the pages on the PPT. So I know the answers, I know the solutions to most of them. But still I start with I start with steps the way students think, because you need to also go through all these questions practically. You need to go through this process practically. Okay. So even if we have taken with h comma k, once if you identify that there is a simple pattern among the coordinates, you can always switch to x comma y, because anyways you have to switch to x comma y at the end. Okay. So this way we can solve this problem. Come on, take a snapshot of this. Okay, next, a circle concentric with an ellipse passes through foci f1 and f2 and cuts ellipse at 4 points p, q, r, s. If major axis is 17, that means 2a is going to be 17, it is given, and area of p f1 f2 is 30. Okay, area of p f1 f2 is given as 30. Find the distance between the foci. So distance between foci is basically SS dash, that is going to be 2AE. Okay, so here F1, F2 are the foci. Okay, so in the question it is given that F1, F2 are the foci. So let's use only the F1, F2 notation. Okay, find the distance between the foci. So let me just draw the diagram and try to understand it. Okay, so we have one ellipse and there is one circle which is passing through the foci. So let me draw this circle in red. So having this as the diameter, if we draw one circle, we may get one circle like this. Okay. So imagine that this is a circle, it's not looking like a circle. Let's make it look like a circle. Okay. So we have 4 points here, P, Q, R, S, these are the 4 points and it is passing through the foci. So these are the foci. Okay. So we can take these foci as, let us say, F1 and F2. Now it is going to be concentric with the ellipse and it is also passing through F1, F2, that means F1, F2 must be diameter of the circle. So equation of circle can be written as x square plus y square equal to a square into e square. That is the equation of the circle and we know the equation of the ellipse in the standard form. Okay, so now let us proceed for the other cases. So circle concentric with an ellipse passes through this, we have used this information and at 4 points we have used that information and 2a is 17, that we will use little later. And that is it, area of the triangle is given, which is P F1 F2 is equal to 30. So delta P F1 F2 is going to be 30. Now let me just do it in a different way. From P, if I join F1 and F2, from P, if I join F1 and F2, this angle must be 90 degrees because the point P is already on the circle. So, we can say that if F1 F2 is the diameter, it must make 90 degrees on the circle. So, which means PF2 and PF1, these two must be perpendicular. So, for this area of triangle, if I use half base into height by taking PF1 as base and PF2 as height, then I can get the area. So, for area, I will use this formula, that half into PF1 into PF2, this must be 30. That means PF1 into PF2 must be 60. We got one information here. And also, what is the other information we got? Other information we got is directly from here, okay? Because it is given that major axis is 17. So, we can say that PF1 plus PF2 is going to be 17, and product of these two numbers, PF1 into PF2, is going to be 60. We have to solve for PF1 and PF2. Can we not do it directly? Of course, I am seeing some factors here. 12 plus 5 is 17, 12 into 5 is 60. Okay. So, you can directly solve them, or you can directly use it here also. Okay. So, here we are getting basically PF1, let us take that as the smaller one, is 5, and PF2 is coming out to be 12. You can also solve it directly by using simple quadratic ideas. Let us say we have idea like A plus B, so we cannot use A and B. R1 plus R2 is equal to 17, and R1 R2 is equal to 60. So, we instead of R2 we can put 60 by R1 equal to 17 and solve this quadratic equation. Whatever are the solutions we get will be basically these values. Okay. Okay. So, now what is the other case? We have to find the distance between the foci. Because this is already a right angle triangle, if we apply directly the Pythagoras theorem on this Pf1, Pf2 and F1, F2, we can directly get F1, F2. Okay. So, we can say that F1, F2 is going to be root of 5 square plus 12 square. You know these numbers, 5, 12 and 13 are the Pythagoras triplets. So, you can say that this is going to be 13. Okay. So, the value of the distance between foci is going to be 13. We have solved this problem using pure geometry. If you have observed, we have not used much concepts of ellipse here. We have used the pure geometry, right angle triangles and circles. Okay. Come on, take a note of this. Okay. Next question. A variable ellipse of fixed major and minor axis slips between two mutually perpendicular lines. Then the locus of its center is. Okay. So, that means we have two perpendicular lines. We can take them as x and y axis, and there is an ellipse which is slipping here. Okay. So, we can take the ellipse somewhat like this. Okay. So, let us say this is the ellipse which is slipping, that means ellipse can move. A variable ellipse of fixed major and minor axis, that means here this length is fixed and this length is also fixed. Okay. So, we can say that 2a is fixed and 2b is also fixed. So, that means we can take 2a and 2b as two constants which we can use for our problem solving. Okay. So, in the answer also if I get 2a and 2b, so it is perfectly fine because these are given to be constants. Now, let us look at the other cases. Then the locus of its center is. So, we want to find locus of the center here. So, how do we solve this problem? So, if we take this locus point as let us say h comma k, okay, then the distance of this point from the origin must be equal to the a square plus b square, okay, because these two lines are perpendicular, So that means what happens here is perpendicular tangents, the point of intersection of perpendicular tangents is basically a point lying on director circle. So from the point of intersection of the perpendicular tangents, if we join the center of the ellipse, that must become the radius of the director circle. And here if A and B are fixed, the radius of director circle also must be fixed, which is the a square plus b square. So that means basically what are we getting as the locus? The distance of that point h comma k from the origin is always coming out to be, this is always coming out to be root of a square plus b square, which is the radius of the director circle, because no matter in which orientation the ellipse is, these two lines are always perpendicular tangents, okay. So we can say that h square plus k square equal to a square plus b square is the locus of that center. So what is the question? Then locus of the center is, of course, it is a circle, okay. So this way we can solve it using pure concept, but to solve this question we need the knowledge of director circle. If we do not know about director circle, then probably we will fail in solving this problem, okay. Can we move on to the next question? Okay. Ellipse has foci and touches x axis. Find its area. So let us understand this using simple diagram. There is one point which is 3, 4. So let us say there is 3, 4 here, and these are the foci. So let us name this as F1, and another focus which is 15, 9. So let us name this as F2, okay. And it touches x axis. So whatever is the ellipse here that we will get, that has to touch x axis, okay. So let us say it is touching x axis here, okay. Now we have to find the area of the ellipse. So to find the area of the ellipse, we need a and b, because area of the ellipse is going to be always pi into AB. It is going to be pi into AB. Now what is A here? It is not given, only foci are given. We can get the distance between foci, but that will give us only 2AE, it will not give us anything else, okay. So but let us just take all the data that is given in the question and understand the data, then we will derive the data that is required, okay. So here we get 2AE is equal to, what is the distance between these two? Root of 15 minus 3 whole square plus 9 minus 4 whole square, which is going to be root of 12 square plus 5 square. So again this is a Pythagoras triplet, which is, this will give you 13, okay. So we got 2AE is equal to 13. Let us look for the other cases. Now these are two foci, and we can understand that x axis is going to be one tangent. Now is there any property that will connect the foci to directly with the tangent? Both foci must be involved. Is there any property that we have learned today? Of course there is one. What is it? Product of perpendiculars from the foci to any tangent must be equal to b square. So if I take this as d1, if I take this as d2, then d1 into d2 must be equal to b square. We have just proved this property. So that means what is the distance of f1 from x axis? It is basically the y coordinate. Similarly for f2 also, it is the y coordinate. So let us just multiply the y coordinates, then that must give us the b square. So here 4 into 9 must be equal to b square. So 4 into 9 is 36. So that means b must be equal to 6. So we got b here, we got a into e here. Can we not derive the other unknowns? Of course, now we can derive it. Okay, because we know that a square minus a square into e square is going to be what? It's going to be b square. So we have b square to be 36 here, and we have a square e square also directly from here. So a square e square is going to be 13 by 2 whole square plus what is b square? It is the 36. Okay. So here we will get 13 square plus this is the 4 into 36 divided by 4. Now 13 square is going to be 169. So let us do some rough work here. 169 and 36 into 4 is going to be 144. So when we simplify these, what do we get? We get 3 here and we get 1 here, 1. So 1 here, it is 213. Okay, so we are doing any mistake here. Okay, so nothing is here. So we are getting a as root of 213 by 2. Okay, so I hope we have not done any mistake here. Okay, so now we got a, we got b also, b is 6. So we can get the area using pi ab. Okay, so that way we can proceed with the problem, and I think this kind of analysis of properties and application of properties are always touched when it comes to the mains level exams and also advanced level exams. Okay, come on, quickly make a note of this. Okay. Next question. A variable ellipse has one focus fixed, okay, and touches two fixed intersecting lines. Then locus of its center is. So let's say let's take the ellipse like this. One focus is already fixed, it's given. So we don't know that fixed focus. So let us just take one ellipse here. Okay. So let's say I have taken one ellipse here and one focus is fixed. We don't know that focus, but we can take one fixed point depending on our convenience. Okay. So it touches two fixed intersecting lines. So then let's fix two lines which are already intersecting, then locus of its center. Okay. So let's say there are two lines which are already intersecting. Okay. So let me take two lines like this. Now this ellipse is varying, but focus is fixed and these two lines are also fixed. So then find the locus of its center. So what I'll do is, I'll take any one of these points as origin for simplicity, or I can also take the focus as AE, 0 and take this point as some other fixed point on x axis. So basically I can take this line as x axis. Okay. So let me take this point as, let's say, some C, 0. Okay. So through C, 0 we are having two lines and these two lines also must be fixed. Okay. So let me just check if there is any faster method here. Okay. So, we will do it like this. If I take the center of this ellipse to be, let us say, h comma k. If I take the center of this ellipse to be h comma k, then the perpendicular that I draw to these lines must be at a distance of a units from the center. Okay. So, if I, let us say, take this point as let us say some constant d comma 0, okay, because these are all fixed values. Okay. And what is a? A becomes the major axis, length of the semi major axis. So, that means from this point also, from this line also, the distance must be a only. Okay. So, using this idea, we can try to get the locus of h comma k. But this point focus is fixed, this point of intersection is fixed, and these two lines are also fixed. Okay. So, if I, let us say, take these two lines as symmetric lines for simplicity, because I am taking this x as the angle bisector of this. Okay. So, then so let us say if I take this as y equal to, let us say, some m into x. So, if I put c comma 0, it must satisfy. So, it becomes plus minus cm. Okay. Then again, this also can be taken as, let us say, with minus m, or you can also fix it as, fix one slope as m1 and second slope as m2. So, we can take this line as y equal to minus mx plus cm. So, let us say I have taken two lines which are symmetric lines. Okay. So, now let me see if it is possible here. Okay. So, distance, perpendicular distance of h comma k from this must be a, and perpendicular distance from this also must be equal to a. So, using that we will get some relation here. Okay. So, let me just get that relation. So, a square must be equal to, if I put h comma k here, so what do I get? mh minus k minus cm divided by root of 1 plus m square whole square. This is one term, and the next one is going to be, a square is going to be mh minus k plus cm by root of 1 plus m square whole square. Okay. Now, further what do we want to eliminate here? What are the things that we do not know here? M is fixed because line is fixed, so that means minus m is also fixed. C comma 0 is fixed, so c is a constant. D comma 0 is fixed, so d is a constant. And then a is something that we have assumed, we can eliminate a. Okay. So, okay, so here there is one mistake that I have applied. I have applied the property in a wrong way. Okay. So, let me just correct it and simplify this. So, that is what. So, when I was solving, I was thinking there is something that is wrong here. Okay. So, now I will just explain the method. Due to time constraint, maybe I will not be able to finish this, but I will finish this in the next lecture anyway. So, from the focus we are basically drawing foot. Okay. So, if I take the focus from here, so from the focus I am drawing foot of perpendicular to both the lines, and when I join these two, the distance is going to be a units. That is the idea. So, what we will try to do is, we will try to get the feet of perpendicular directly here. Okay. So, apply the formula for feet of perpendicular, and then apply, after we get one point, apply distance between these two must be equal to a, and then try to solve this. There is also one more property through which we can solve this, but we will discuss that in the next lecture. Okay. So, try solving this at your home. We will meet again with this problem in the next lecture. Until then, have a great learning day. Learning shall never stop.